lab at the Microelectronics Research Center to demonstrate the new digital temperature controllers that we have installed. But before we do that, we will show you how the old analog systems work. If you look down here, these mess was the old controller. And you see this is an old analog controller right here. This is what the internal of that was. Now to this whole system, this system, and this was all used for just one temperature controller. For those who are interested, this here was an op-amp. So that gives you an idea of how old this really was. Now this is the new controllers that we have put in. As you can see, they're much smaller than the old ones. And another big advantage is that one controller controls two ovens, unlike the old system. So we're able to save a lot of room. Another feature we have are these indicator LEDs, which you can see above all of these breakers. Now this is for oven 1, oven 2, oven 3, and oven 4. Now the indicator lights will tell you which parts of the oven are getting power. The front light is on, that means the front part of the oven has power, center, and so forth. Now if you take a look at the inside, come closer. Now the main part of our design came with the development of these boards. Since we had a high power system and a low powered system controlling it, we needed to use something to isolate the two systems. Now this board has these chips here which are called opto-isolators. They allow us to isolate the high powered AC voltages from the low powered DC voltages from the controller. Now these hookups here come from the controller, which when on will turn on a pair of SCRs, which lets voltages flow in both directions for one zone. So each of these pairs here goes to a zone, and we have 3 different control wires to control each zone. And if you look, put it down more. And if you look in here, these are the thermocouples coming from the oven that goes into each zone. Now a better schematic of this will be shown in our report. Okay, the controller cycles through each zone and tells you what temperature it is. Now zone 1 is at 150, 160 degrees, zone 2, 150 degrees, zone 3, 180 degrees. Now once one of those 3 zones gets up to 300, the LED should shut off and no more power will be applied. For our first demonstration, we will set these controllers manually. Now there are 6 zones which correspond to zone 1, zone 2, zone 3 of oven 1, zone 4, zone 5, zone 6, that's oven 2. So, to set these, set to 72, set that to 72, 36. Alright, so this is zone 1 that we're setting right now. We'll set that to 300 degrees. Now zone 2, which is the middle zone of the first oven, we'll also set to 300. And zone 3 the last zone of the first oven, and we'll set to 300 as well. Now zone 4 is going to be for the second oven. We'll set that to 350 degrees. Zone 5 we'll also set to 350 degrees, which is the center zone of the second oven. And zone 6 we also set to 350 degrees, which is the last zone of the first oven. Now the controller cycles through and lets you know what the temperature is of each zone. Now, as you can see, all the zones are under our set point, and all 3 LEDs are on for both ovens. We do have our 30 volts. Now in the center zone, we have our 60, last zone, we have our 30. Now, 3 LEDs down here are on for the second oven as well, so we should expect the same. 30, 60, 30. Now, as we can see, we're getting closer. The temperatures are increasing. Once they get up to their point, the LED will shut off and power will no longer be in one of those zones. See, one of the LEDs went out because the temperature got up to its 300 degrees. Now the crew, no volts, 0.3 volts, which is nothing. This still has 60, LED is still lit, and the temperature is still below 300. Here, we have 30, LED is still lit, and that is also below 300 degrees. So that shows that the controller is operating as it should be. It is on when it's below its temperature, and it is off when it's above the temperature, or it's at the temperature.
So as you can see here, the Mac Mini is acting as our web server, and we have USB to serial adapters, and these cables are connected to the RS-232 ports of the controller. So I'm going to show you the software. So this is a website that we built. So these columns represent the ovens. As you can see, we have 4 ovens. And then for each oven, we can set the temperature of each zone individually. We have 3 zones for each oven. So for the demo here, I'm gonna set the 3 zones of oven 1 to 400, and then for oven 2 to 500. So as you can see, we have 400 for zone 2, 400 for zone 3, and then 500 for zone 4. So that means the second oven is getting 500, while the first oven is getting 400. And we can double check here too. $400, $500, and we can read the current temperatures too. These are the current temperatures. As you can see, it's raising for both ovens. So
what we've demonstrated so far shows that the controllers do work. One of the big issues, of course, is this is strictly on-off. That's how we have the controller set right now. In the very near future, it's going to have a PID controller, which will help us prevent having such a large overshoot. because now the power stays on all the way up until it gets to that temperature. The problem with that is we have a large overshoot, so the temperature goes over what we want. PID control allows us to have a much smaller overshoot, and we can control how the power will be pulsed on and off, and it'll go slower as it gets closer to the set point. This will take some time and some calibration, but we should have that done before the end of the semester. I'm James Scrow, the team leader. This is
I'm Rakam Sapaga, the project specialist.
I'm the webmaster.
I'm Joe Gurney, the chief analyst.
Flip it around and say your name.
I'm Victor Villagomez, software engineer.
Good enough. And
Hello.
just say your name and
I'm
we'll
Gary
start.
Tuttle. I'm supposedly the